Hello friends, and welcome to a problem in operation research. Today we will take up an airline staffing problem. Now the problem is that the airline adds more flights and it has to hire agents to put them on the customer desk to handle the additional load of passengers. The management team has made a research on how much is the minimum number of agents required for a 2-hour period in the entire day. Like you can see from 6 a.m. to 8 a.m., the minimum number of agents required is 48. From 8 a.m. to 10 a.m., it's 79. Similarly, if you go down, you'll find that in the midnight, that is from 6 a.m. midnight to 6 a.m., it's 15. Now, the agents can be called only in particular shifts. Shift number 1 starts from 6 a.m. and ends at 2 p.m. Shift number 2 starts from 8 a.m. and ends at 4 p.m. Shift number 3 starts at 12, that is 12 noon, and ends at 8 p.m. Shift number 4 starts at 4 p.m. and ends at midnight. And from midnight to 6 a.m. you have the last shift. The cost of hiring agents per shift is given in the bottommost row. If the agent comes in the first shift, he has to be paid $170 a day. If he comes in the second shift, it's 160. The third shift, it's 175. Fourth shift, it is 180. And fifth shift, it is 195. The problem here is, how do we decide how many agents should we call per shift so that the cost of hiring them per day is minimized? So the variables here are x1, x2 till x5, where x stands for the number of agents in a particular shift, where x1, for example, stands for the number of agents in shift number 1. X2 stands for the number of agents in shift number 2, and so on and so forth. The objective function here is z is equal to, it's given 170x1 plus 160x2 plus 175x3, 180x4, 195x5, where 170, 160, 175, 180 and 195 are the costs of calling the agents in any particular shift, and x1, x2, x3, x4 are the number of agents in those shifts. The constraints here are that the minimum number of agents in shift number 1 for the period of 6 a.m. to 8 a.m. should be greater than 48. Similarly, the other constraint is that the total number of agents in shift number 1 and 2 should add up to greater than 79 for a period of 8 a.m. to 12 noon. As you can see here, from 8 a.m. to 12 noon, you require a minimum number of 79, and then this is followed by a minimum number of 65 from 10 a.m. to 12 noon a.m. So you have to take the greater of the two. Now, in the third constraint is that the minimum number of agents in shift number 1, 2 and 3 should add up to 87 for a period of noon to 2 p.m. Similarly, all other constraints are defined. They are all self-explanatory. And let's see how we can solve the problem using Excel solver. Now, this is the Excel sheet, and how do we solve it? Let's have a look at it. First, we enter the variables. That is the number of agents in shift. So we enter the variables of it. Then we enter the cost, that is 170, 160, 175, 180, 195. Then here we enter a guess for the value of number of agents in the shifts. So for x1 we guess a value of 10, for x2 we guess a value of 10, and it is just a guess. Okay. Now we write here sum product and we select the costs, and then we select the number of agents and enter. Now this gives you the value of the objective function at the number of agents that you have just defined, that is 10 per shift. Now let us go ahead with constraints. Now the constraints here are x1 greater than equal to 48. So under x1 we just add or enter 1 here. Now x1 plus x2 greater than equal to 79. So under x1 and x2 we just write 1 and 1, and we complete this for each and every constraint that we have here. Okay, so these are the constraints. The constraints were also discussed earlier. So we just enter 1. And then in this row, what do? Is we write sum product. Then copy down this entire row or select it. And then select this entire row, that is the value of the variables. Select it once again and press F4, function F4. So this will make it an absolute cell reference. Now we drag and get it till the bottom. Now to solve it, we go to data, we go to solver. Let me delete the previous one, click add. Select all the values, the current values for the constraints, and all the constraints have to be greater than equal to, and then afterwards we select the maximum or the minimum value of the constraints. Click OK, click solve, and there we have our answer. The number of agents that have to come in the first shift is 48, which is followed by in the second shift it's 31, third shift it's 39, fourth shift it's 43, and fifth shift it's 15. Now the interesting part here is, since the constraint was greater than equal to, what you will find is in few shifts, that is not few shifts but few time periods, that is the time period from noon to 2 p.m. you will find that the number of agents coming is 118, available is 118, but the minimum required was 87. Similarly, in the time following that, that is from 2 p.m. to 6 p.m., 2 p.m. to 4 p.m., it's 70, but the requirement was 64. Now, why does this happen? It happens because we need to minimize the cost while seeing to it that at least the minimum number of agents are available per shift. Now, we get an excess because what happens is that the shifts overlap. Mind you here, what happens here is, for this particular time period, that is noon to 2 p.m., shift number 1, 2 and 3, they overlap. Therefore, it is but natural that in the results, if you have to maintain minimum number of people in shift number 1, 2 and 3, if they run parallelly, it's going to exceed. So that is the reason. Okay, let's do something. In this same problem, what if we put a condition that for noon to 2 p.m., let us ensure that the total number of agents don't exceed 87. Can this be solved in the solver? Well, the answer is yes. But what would be the answer? Why don't you solve it? Put your answers in the comment section and let's see. It gets much more interesting. Once again, I have used solver to solve this problem. Remember, linear programming is not any area worth studying if you don't use computers. Linear programming became popular only because of computers. If you do not use computers to solve challenging linear programming problems, well, my friends, you have learned nothing. And Excel is perhaps the best tool to start and, if possible, use it professionally. That was all. Goodbye, friends. Have a great time and do like and subscribe my channel and do share this video with your friends. Have a great day.